TR-069 is a broadband forum technical specification entitled CPE1 Management Protocol. It defines an application layer protocol for remote management of end-user devices. As a bidirectional SOAP HTTP-based protocol, it provides the communication between customer premises equipment and auto-configuration servers. It includes both a safe auto-configuration and the control of other CPE management functions within an integrated framework. The protocol addressed the growing number of different Internet access devices such as modems, routers, gateways, set-top boxes, and VoIP phones for the end users. The TR-069 standard was developed for automatic configuration of these devices with auto-configuration servers. The technical specifications are managed and published by the Broadband Forum. TR-069 was first published in May 2004, with amendments in 2006, 2007, 2010, July 2011 to version 1.3 and November 2013 to version 1.4. Other forums, such as the Home Gateway Initiative, Digital Video Broadcasting and WiMAX Forum endorsed CWMP as the protocol for remote management of home network devices and terminals. There is a growing trend to add TR-069 management functionality to home networking devices behind the gateway, as well as many other access devices like M2M, FTTH cape-ons, WiMAX cape and other carrier access equipment. Communication between the device and ACS. Transport details. CWMP is a text-based protocol. Orders sent between the device and auto-configuration server are transported over HTTP. At this level, CPE is behaving in the role of client and ACS in the role of HTTP server. This essentially means that control over the flow of the provisioning session is the sole responsibility of the device. Provisioning session. All communications and operations are performed in the scope of the provisioning session. The session is always started by the device, CPE, and begins with the transmission of an inform message. Its reception and readiness of the server for the session is indicated by an inform response message. That concludes the session initialization stage. The order of the next two stages depends on the value of the flag hold requests. If the value is false, the initialization stage is followed by the transmission of device requests, otherwise ACS orders are transmitted first. The following description assumes the value is false. In the second stage, orders are transmitted from the device to the ACS. Even though the protocol defines multiple methods that may be invoked by the device on the ACS, only one is commonly found: transfer complete, which is used to inform the ACS of the completion of a file transfer previously issued download or upload request. This stage is finalized by transmission of empty HTTP request to the ACS. In the third stage, the roles change on the CWMP level. The HTTP response for the empty HTTP request by the device will contain a CWMP request from the ACS. This will subsequently be followed by an HTTP request containing a CWMP response for the previous CWMP request. Multiple orders may be transmitted one by one. This stage is terminated by an empty HTTP response from the ACS indicating that no more orders are pending. Security and authentication. As vital data may be transmitted to CPE via CWMP, it is essential to provide secure transport channel and always authenticate the CPE against the ACS. Secure transport and authentication of the ACS identity can easily be provided by usage of HTTPS and verification of ACS certificate. Authentication of the CPE is more problematic. The identity of the device is verified based on a shared secret at the HTTP level. Passwords may be negotiated between the parties at every provisioning session. When the device contacts the ACS for the first time, default passwords are used. In large networks, it is the responsibility of the procurement to ensure each device is using unique credentials. Their list is delivered with the devices themselves and secured. Connection request. Because initialization and control of the provisioning session flow is the sole responsibility of the device, it is necessary for the ACS to be able to request a session start from the device. The connection request mechanism is also based on HTTP. In this case, the device is put in the role of HTTP server. The ACS requests a connection from the device by visiting a negotiated URL and performing HTTP authentication. A shared secret is also negotiated with the device in advance to prevent the usage of CPEs for DDoS attacks on the provisioning server. After confirmation is sent by the device, the provisioning session should be started as soon as possible and not later than 30 seconds after confirmation is transmitted. CR over NAT. The CWMP protocol also defines a mechanism for reaching the devices that are connected behind NAT. This mechanism, based on STUN and UDP NAT traversal, is defined in document TR-069 Annex G. Amendment 5 of the protocol introduces alternative method of executing connection request via NAT based on XMPP. Data model. Most of the configuration and diagnostics is performed through setting and retrieving the value of the device parameters. These are organized in a well-defined hierarchical structure that is more or less common to all device models and manufacturers. Broadband Forum publishes its data model standards in two formats: XML files containing a detailed specification of each subsequent data model and all of the changes between their versions, and PDF files containing human-readable details. Supported standards and extensions should be clearly marked in the device data model. This should be in the field device summary or Internet Gateway device summary, which is required starting from device 1.0 and Internet Gateway device 1.1 respectively. If the field is not found, Internet Gateway device 1.0 is implied. As of device 1.4 and Internet Gateway device 1.6, new field for supported standards specification was introduced. The model is always rooted in the single key named device or Internet Gateway device depending on the manufacturer's choice. At each level of the structure, objects and parameters are allowed. Keys are constructed by concatenating the names of objects and parameter using ... as a separator, for example Internet Gateway device timed server 1. Each of the parameters may be marked as writable or non-writable. This is reported by the device and get parameter names response e-message. The device should not permit the change of any parameter marked as read-only. Data model specifications and extensions clearly mark required status of most of the parameters. Values applicable for the parameter, their type and meaning are also precisely defined by the standard. Multi-instance objects. Some parts of the data model require the existence of multiple copies of the subtree. The best examples are those describing tables, for example port forwarding table. An object representing an array will only have instance numbers or alias names as its children. A multi-instance object may be writable or read-only depending on the data represented. If, for example, the object represents 4 physical ports on a switch, it should not be possible to add or remove them from the data model. If an instance is added to an object, an identifier is assigned. After being assigned, identifiers may not change during the life cycle of the device except for factory reset. Common problems. Even though the list of the parameters and their attributes is well defined, most of the devices do not follow standards completely. Most common problems include missing parameters, omitted instance identifiers, wrong parameter access level, and correctly using only defined valid values. For example, for the field that indicates supported standard of WLAN protocols, the value G should indicate support of 802.11b and 802.11g, and G only support only of 802.11g. Even though values such as BG or BG are not legal according to the Broadband Forum standards, they are very commonly found in device data models. Common operations. The whole provisioning is built on top of a defined set of simple operations. Each order is considered atomic, though there is no support of transactions. If the device cannot fulfill the order, a proper error needs to be returned to the ACS. The device should never break the provisioning session. High-level operations possible through Technical Report 069, Service Activation and Reconfiguration, Initial configuration of the service as part of zero-touch or one-touch configuration process, Service re-establishment. Remote subscriber support, verification of the device status and functionality, manual reconfiguration, firmware and configuration management, firmware upgrade downgrade, configuration backup restore, diagnostics and monitoring, throughput and connectivity diagnostics, parameter value retrieval, log file retrieval. See also, wireless router, references. External links, TR-069 Issue 1 Amendment 5 CPE1 Management Protocol v1.4, CPE1 Management Protocol CWMP XML Schemas and Data Model Definitions, Marketing Report Trail 069 Deployment Scenarios, Issue 1, August 2010.